Hello, 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 everybody, and welcome to the next edition of STATURDAY Chat Live here on September 24th, 2022. So a big day in the live stream. We have some amazing guests. If you haven't been paying attention on YouTube and LinkedIn, sorry, but we have some amazing guests. If you're just signing in, and just know, we have two amazing educators and authors here on the channel. You probably saw their faces at the beginning. But we do have Peter Bruce and Grant Fleming coming up to talk about responsible data science and all the elements that go into responsible data science, and then most importantly, why you, if you're not already, be thinking about the concepts and ideas around responsible data science. And we're going to have some giveaways at the end of the stream. So if you like free stuff, who doesn't like free stuff? Make sure you hang around to the end of the stream. We're going to do 2 book giveaways. I think they're actually signed books. So make sure you hang around for that. Okay. So a few odds and ends before I bring in Peter and Grant to talk about responsible data science. First things first is that not next week, but the week after next, I will be in Germany, if you remember. So I'm going to Germany for 2 weeks. I don't know if I'm going to be able to stream from Germany. I might look into it. So if I do stream, it'll be somewhere in Germany, Bonn or Cologne or something like that. So if you don't see me for a few weeks, it's just because I'm traveling and I don't know what the internet situation is going to be while I'm traveling. So just hang with me and I will be back eventually. So yeah, just keep that in mind. Also, if you haven't been sort of watching, I do have a new series of videos coming out on YouTube on time series analysis. So it's just getting started. So we have several videos already up. This is the first one and the second one. The third one is already up now, and a fourth one is going to be released on Monday morning in the AM. So make sure you check out that new series on time series. That's the first of just many, many videos to come on that topic. Probably years in the making. All right, so what we got here? Raghav, hello, Brandon. Good to see you from India, from Bangalore. Hope you're doing better over there right now. It's good to see you. Thanks for stopping by. Joseph, good to have you, my friend. Thanks for coming by. Glad you're here on the stream. Hello, everybody. Excellent. So it's good to see you all. Good to see you all. All right, I think that's all the odds and ends that I have. Abdul, it's good to see you, my friend. Glad you're doing well. From Pakistan. Excellent. Good to see you. All right. So I don't want to waste too much time on all this sort of stuff. So I want to, jump right in and bring in our guests so you can begin, talking with them and everything. So I'm going to bring them on in a second. So I'm going to add them to the stream. And they are here. So hello. Hello, Peter. Hello, Grant. How are y'all doing this morning?
Hi, Brandon. How are you?
Excellent. Grant, doing all right?
Also doing quite well. I just finished a bottle of Soylent. I promise that's not product placement, but that was lunch today. So feeling all right.
Excellent. Good. Well, I'm so glad you all stopped by the live stream. You have like 20 people watching right now, which is really good. So we're going to just sort of dive right in. And why don't you, Peter first and then Grant, why don't you just give us the 1 or 2 lines sort of about yourself and your sort of career journey and what you currently do. Peter first.
Yeah, well, I've been in this business actually a long time. I was a co-author on a book called Data Mining for Business Intelligence was the original title. Mm-hmm. And that gives you a sense of how long ago that was. So the term data mining is not one used favorably now. And business intelligence also means something completely different from data science and machine learning. And I founded statistics.com, sort of a more statistically oriented training and education platform. Back in 2002, I think we were perhaps one of the original online learners, certainly the first online company in the area of data science education.
And here it is. So that's the website. Everyone can check it out. We'll get to that more here in a second. Grant.
Absolutely, yeah. I'm Grant Fleming. I'm a senior data scientist at Elder Research and a coworker of Peter's. I've been here for about 3.5 years, and I work on various projects in private, but mostly public consulting. So I do various projects in the data science, artificial intelligence, machine learning space with the US government. And that work keeps me quite busy, but somehow on the side, we do have professional development time at our company, fortunately. And Peter and I did coordinate and end up publishing Responsible Data Science.
Mm-hmm. This one right here.
Yeah.
And right there.
Since then, been contributing to courses on that subject and getting the word out.
Excellent. So glad to have you all here. And I forgot to mention to the chat, everyone in the chat watching on the live stream, most of this time we want to spend having you all put questions or comments in the chat, and then I'll bring those up on the screen. And then Peter and Grant are going to do their best to answer the questions that you put in the live chat. Of course, we may not get to all of them once the chat sort of gets going. And they also have the right not to answer a question if they feel like they don't want to or whatever else. That's their prerogative. So go ahead and start putting, I want you to put two things in the chat, everybody. I want to put where you're watching from. That's always where I always want to know where you're watching from. And any questions around data science, responsible data science, machine learning, and things of that nature in the chat. And then I'll bring those up here in a few minutes so they can answer them for you. So I think one of the first questions we should really, talk about is the elephant sort of in the room. And that is, what is responsible data science? How in the way that you think about it in your writing and in your teaching, and why is it relevant to students or any other learner out there that sometimes, I'm guilty of it too, can just, get, oh, there's this awesome data set. I'm going to load it into R or whatever else I'm going to do and just run this model on it and then see what it gives me. But we don't necessarily often think about the context around that. So what is responsible data science as you conceive of it? And either one of you can start.
Why don't you go, Grant, and then I can chime in.
Sure. Yeah, so I'll say from my end that this is definitely something that people may have various different views on, and Peter and I's views are not necessarily the authoritative view, but we do think it is a reasonable view, and we found that people tend to agree. And so for me at least, responsible data science is the recognition that a typical data science process, purely done from a technical perspective of, I want to use a set of data, I want to get a model that has the best performance on this data, and I want to put that out into the world. It's primarily a technical focus based on maximizing predictive performance. That in that process, there are certain systematic blind spots that we are missing, that a responsible data science frame of thinking can help us bring attention to and address. And those blind spots manifest mostly in two ways. So one is that, when we build these models, even if we have really performant models that generate mostly accurate predictions, what actually happens when those predictions are used to influence activities or policies in the real world? The consequences that you get from a model that's 100% accurate, if that model is aimed to do something harmful, could be quite significant. And so it's our duty as data scientists, as analytics professionals, to sort of evaluate the real world impacts of our models and keep that in mind as something that we need to be partially mitigating and controlling. And the second part is, even if we're not necessarily concerned about the real world impacts of our models, because maybe the model is relatively benign, it's just serving ads or predicting click-through rates or similar, there are certain technical evaluation steps or model interpretability steps that could help us reduce the errors within our models very, very consistently and help us understand our models better, to see how they may react to new and different kinds of data, and putting those practices into practice.
Excellent.
And
Peter?
And I'd say there's a historical foundational basis for responsible data science that even predates this understanding of all these harms that have made the news, which is sort of a professional best practices process. And it became codified early on in the CRISP DM process, and the responsible data science process that we've talked about sort of overlays and integrates with that so that you have considerations of unintentional harm and various ethical issues layered on top of the somewhat more professional, somewhat more technical consideration than the Chris DM process, which in itself was striving to get away from a purely technical focus. It stressed the need to understand the business or organizational context of a problem, the need to understand and be responsible for the data, where it comes from and what transformations you're making to it, and having an audit trail for the data. So some of these elements have long been around. It's on the more recent thing is translating them into what they mean and what the importance is for the ethical practice of data science, which is another term you hear a lot of, ethics versus responsible data science.
Excellent. Yeah, we do have some comments coming up in the chat, which I'll put up here in a few minutes. So if you're watching, I'm going to ask Peter and Grant a few questions here first, and then I'll bring up some of your comments and questions, and then we'll go through those sort of after sort of the Q&A. So I will get to those. Don't think I'm ignoring them. I will get to those. So one question I have too is, can you think of maybe one or two examples? And I've read through the book. You can see it's all bent. So there are many in the book. But is there one example of irresponsible data science that really stands out to you, and maybe the more recent, the more value might be to the watchers. But is there an example that really stands out as something we should use, sort of as a model of why this is important?
Yeah, we've looked at a bunch. Maybe I'll do one, and you do one,
Sure.
Grant. And
Sounds good.
The one that I often think of is and it's actually quite famous now, the Optum Health problem. A company that developed a predictive algorithm that was really designed to help improve healthcare by predicting when somebody who'd been in the hospital might need to come back for follow-up treatment to minimize the chance of more serious complications, so that they wouldn't go untended. And its predictive performance turned out to be inferior for African Americans. It underpredicted their need for future healthcare follow-up after a procedure, largely because of I guess I would call it a technical error, that the dominant predictor in this case was prior spending on healthcare, and it turned out that African Americans had spent less on healthcare, probably due to lack of either access or resources, than white Americans, and therefore were predicted to spend less in the future on healthcare. Didn't mean they needed it less, and in fact, detailed analysis showed that people with similar conditions, similar circumstances, if they were African American, they were not forecast to have to come back as soon as the white Americans with the exactly identical circumstances, due to the power of this predictor of prior spending.
Yeah, I think that was one of the first examples you talked about, sort of in that book, and it really set the stage for some of the other examples. So thanks for sharing that. And Grant, anything you can think of as a quintessential, example of irresponsible data science, or at least things that should have been paid attention to? We're not saying necessarily these are intentional, right? Like,
Right.
A lot of this stuff is not, most of it, if not all of it, is not intentional. And there might be some intentionality things I'll get to in a second, but we're not saying that these are mean people doing bad things necessarily. Grant, anything come to mind?
Right. Yeah. Something does come to mind, and I'll mention that. But Brandon, you do bring up a good point. I think this is relevant for all of us as practitioners or soon to be practitioners in this field, that it is not purely people who intend to cause harm who do cause harm with the data or the data science models that they publish and that go out in the world. It's just the fact that if there are certain oversights in these processes, the potential for unintended harm is there. And that is, in large part why this is an issue that's relevant to all of us. So I'll start with that. But one other example that I'll bring up, this is a pretty canonical example in the context of responsible data science, is the Gender Shades project that was created by Dr. Joy Bolamwini with Drs. Timna Gebru and Deborah Raji. And this was a set of work that began in 2016 when a Nigerian American woman, very dark skin, Joy Bolamwini realized that all the sort of face filter and facial recognition type applications that were available on her smartphone were not able to actually recognize her face. And at first she wondered if this is just because the apps were bad, but she had friends who had lighter skin try them and they worked fine. And then she eventually put on a all white mask onto her face and suddenly her face was recognized. And so then the question became, are these apps intentionally discriminatory? Doesn't seem likely. And she actually, being a computer science researcher at MIT at the time, was able to gather a bunch of data and get access to the APIs behind these models to do a project that showed actually that these models had much higher error rates at detecting the gender of darker faces versus lighter faces. And this was in all likelihood due to the fact that people who had darker faces were just not represented, at least not in sufficient amounts, in the data used to train these models. And so it was a very, very large oversight on the behalf of these large companies like Microsoft and IBM and Amazon and Baidu, who had some of the most well-funded research teams in the world, probably some of the smartest people working on these subjects. And yet the models they built failed on any subset of the population anywhere in the world who had skin that was sufficiently dark that they were not represented. And so they actually published their results, and these companies made various responses, but in a period of a year or two actually massively expanded their training data sizes to include a much more diverse variety of faces. And that error rate massively went down. And just goes to show that bringing to light these issues and advocating for them to be fixed can actually result in those fixes being made.
Yeah, it's another great example. And there are so many inadvertent sort of things that seem to come about. One intentional thing I can think about, and I don't want to go too far into the weeds, is how data science is used for gerrymandering, political gerrymandering. So it's possible through these techniques for politicians to pick their voters and not the other way around, because they can create very homogeneous maps and stuff like that, which is an intentional use of techniques to do harm, and maybe not harm in one sense, but still, that's one thing I can think of where it is. I'm not sure if you have any thoughts on that, or there are already examples you can think of that were intentional.
The intentional deployment of machine learning in support of, and I'm going to take it outside of the United States because I think it's more serious elsewhere, of Big Brother and police state regimes to carry to the nth degree the sorts of tracking and suppression of dissent and minorities that those dictators half a century ago could only have dreamt of. Alexander Solzhenitsyn has in his classic novel, The First Circle, a bunch of engineers are tasked with analyzing spectrographic readouts from a voice on a telephone. The voice belonged to somebody who was attempting to convey atomic secrets to the U.S. Embassy. This is a novel. And if you think about that situation, think what would be possible now and the scaling up of that effort in support of police state surveillance and suppression.
Yeah, I mean, it's definitely.
And there's all kinds of machine learning that goes into that. There's the images themselves that are captured, but also identification, matching up to other profiles, entity resolution to clarify who is whom, and just tracking over time.
Yeah, I do personally find the idea of techno surveillance very chilling. Very chilling. So,
And
go ahead.
unfortunately, it's not even something that's fully confined to the governments of the world that maybe are a little bit more totalitarian than maybe certain governments in the West. In both the UK and in the United States, there have been numerous examples of people either being stopped in public or being arrested in the US context, for example, based on a false facial recognition match from a public security camera. And so far, at least in the US context, this is not being heavily regulated at a federal level. So it's likely to continue to be an issue.
Absolutely. You know, but we could talk about that sort of forever. Now, I think obviously you all and others, but you all especially in this conversation, attempt to remedy some of these things through education. And of course, you all teach, and of course, you have your book, Responsible Data Science, of course, but also teach a class in responsible data science on statistics.com. And could you like pair like an issue that we've talked about the past few minutes, and then how like an answer or remedy to that issue is addressed in the course, like through pedagogy, through coding exercises? How do you match the issue with the solution through education in this course?
Yeah, basically the way these courses work is they're typically small cohorts of people, instructor-led but asynchronous, meaning you don't have to be online at any particular time of day. But they take place over a given time period. So everybody gets the same materials, reads the same project, and can interact with their colleagues on a discussion forum and ask questions of both the instructor and teaching assistants. And usually each week, particularly the weeks 2, 3, and 4 are centered around project type exercises where we provide a data set, ask a cascading set of questions, and ask folks to do the model building or model audit or model analysis, and then submit them and ask questions about it. So they'll be doing some coding typically and some interpretation of results.
Through a particular like sort of a case sort of problem?
Yes, usually there's several, and the initial cases are more highly constrained so that you're guided in a very particular direction. And then most courses have a final project that's more open-ended and covers a broader area of analysis. And you're expected to sort of work on that during the whole course, and then ask questions of your instructor, ask questions of other folks in the course, and then provide an analysis.
Do you primarily use R and or Python?
Yes, in most of the courses. There's some courses where in this course, yes, we have R and Python.
Excellent. And Grant, any of your thoughts on how to match up some of the issues we discussed with the actual goals of the course and how those goals are met?
Yeah, so I suppose, for example, a lot of what is at the core of the issue in the facial recognition example that I discussed was dealing with balance in your training data set. And so I don't recall which course we actually do this in, but there is an exercise where we experiment with different balances of data in the training set and see if we track individual like groups within that data, how does the performance for particular groups in that data change as you change the data set balance? And we help the students empirically see that getting a better balance of data in the data that you're training your model on will get you a more even-handed, fair evaluation when you're performing on your test set.
And
then, go ahead.
I was going to say, an important part of this is the calculation of the metrics of fairness that go beyond the standard metrics that you might use in a machine learning project, and just learning how to calculate those, what they mean, and using interpretability methods to figure out what's going on with your model, so that if your model does end up providing biased or unfair results for certain groups, we point the way towards investigating what might be responsible for that, what the roles of different predictor variables are, how they affect the outcome, and if there's something going on there, what can you do about it? And if you can't do anything about changing the predictor variables or altering that behavior, how do you remedy the model in a way that allows it to pass muster from a bias and unfairness perspective?
And do students get sort of feedback on their code? Do they turn in like reports of interpretation? Sort of how's
Yes.
like the assess? I won't say maybe formal assessment, but feedback provided.
Yeah, there is actually assessment. There are model answers that the teaching assistants rely on, and there's sort of two phases. Phase one is where you are working on the problem and you ask questions and try to get past obstacles that you may have in your analysis of the data. And then phase two is you submit your final report or interpretation, and then you can A, compare it to the model answer, and B, get feedback from mentors and teaching assistants as to how you might have gone wrong.
And I'm going to bring this comment or question up because it's on this topic. But Muthu asks, do you think 4 weeks are enough? Because what if someone, are slow learners or just take some time for things to gel, and or are a bit new to coding? Do you think that someone like that could do well in the course, or at least get some valuable info from it?
Well, two sides to that. If you're a little too new to coding for this course, we have a whole series of regular predictive analytics courses that we want to make sure that somebody going into a course like responsible data science has the adequate background both in the coding and the predictive modeling. So those are some familiarity with that is a prerequisite for this. But once you're in the course, you're free to download the materials and continue working on them afterwards. And we're usually kind of lenient about if something happens and you need more time, you can go on.
Okay, absolutely. So like everyone, like we talked about before the show, everyone sort of comes in at their own place, and it's important to know if we don't want people to be frustrated because they get into a course that they.
Yeah, one of the advantages of a small scale operation like this is if we find folks are struggling in a course, then we'll say, hey, you really ought to try this other course first. We'll put you out of this one, put you into that one, and find what works for you.
Excellent. And if everyone in the chat, just if you stopped in recently, at the end of the stream, towards the end, we are going to do some giveaways. So we're going to give away a signed copy of their book, Responsible Data Science, and also give away a copy of Practical Data Statistics for Data Science. We're going to give one of each. We're going to do a giveaway at the end. So make sure you stick around for those if you like free stuff. And you have to be in the chat at that moment to get those. So hang around for that. Another thing, I was sort of curious about, and everyone should know that, of course, this is, statistics.com has partnered with my channel to sort of bring this to students. And if you do take a course, there is a coupon code you can use to get a discount on the course and courses, or programs for that matter. So make sure you check out that in the description if you're interested. And I think the next one starts on October 14th, 2022. So in a few weeks, if you want to get into that cohort, you still have a few weeks to get sort of into that. And then while I have this up and we're talking about statistics.com, this is probably more towards Peter, but Grant, you can chime in if you have some info as well. And then after this, what I want to do is get into some of the questions that people have put in the chat. So in certain situations, students can get college credit for courses they may take on statistics.com. Could you just briefly talk about how it's not automatic, but how that works in those certain situations if students are looking to, gain some college credit at a significantly discounted price?
There's an organization called the American Council on Education, which is a consortium of universities that facilitates the transfer of credit across institutions. So that each institution, when a student requests credit for a certain course they've taken, they don't have to go in and vet the course and investigate what was in that course and is it up to snuff. That's done once by the American Council, and these courses have been evaluated by the American Council and approved for academic credit recommendation, which means that once you finish the course and get a certificate from statistics.com, you take it to the American Council on Education, and they will turn it around and issue a credit recommendation. There's no 100% guarantee that another college will accept it. Some get particular about what they will and won't accept, but it's the best way to get transfer credit or college credit for a course that we offer.
So a student might want to check with their department or registrar first to see if that's something that they could do through their school. Be a good first step.
That's right.
Peter, is it not the case that some of these courses are for undergraduate credit and graduate credit?
Yes, we offer courses at both levels.
Okay.
Excellent. So everyone out there, if you're watching and you're interested in any of the courses on statistics.com, it's important, and you maybe want to get college credit for that, is to contact your school and or department and tell them what you would like to do or would plan to do to make sure that would all flow through and you have sort of like permission ahead of time to successfully complete this course and have that apply towards your course requirements, either for your general requirements or major, depending on where you in the world. It's a bit different, obviously, where you are in the world, but it all goes through your institution first to make sure that this would apply to your course list of courses.
That's right.
So, okay, so let's take some questions. This is the fun part. So, yeah, we're going to do some Q&A, everybody. So if you have some questions for Peter and Grant about responsible data science or just data science in general, machine learning in general, please put those in the chat and they will do their very best to answer those for you. And of course, if they don't think they can answer that at this present time or decline the answer, that is their right. So put your comments and questions in the chat into addition what's already in there, and I will start bringing those up sort of one at a time, and we'll see what kind of conversation we can get going. So first one, Abdul asks, how to approach data science nowadays when once automation is achieved, then data science will start to diminish? ? Question for both Peter and Grant. Either of you want to take this question? Any thoughts on it?
I can take an initial stab at that.
Sure.
Yeah, thanks for the question, Abdul. I'm going to answer that question is basically asking how can we as data scientists still contribute meaningfully to our jobs as the models and processes that we oversee become increasingly automated. I'll say that I do not think yet we're going to be at a point in either now or in the next 2 or 3 years where there will be less demand for data science. There just seems to be growing and growing demand, at least within a US context. That's what I can best speak to. But even as modeling and data storage and data cleaning and the services that sort of support those become more centralized and automated, maybe you have automated data ingest, automated data cleaning, automated modeling and feature selection, and then automated prediction. Even as that occurs, you are always going to need, and companies are going to always demand, that there is a human in the loop who is evaluating these models, making sure that the model predictive performance doesn't drift over time, that features are not being dropped from the model that should be included, that there aren't sort of issues with the data cleaning. And anecdotally, as someone who's worked with some of these tools that purport to be primarily automated, things break and things break often. And I don't see, at least in the near future, there being any less need for people with these skill sets that we all either have or are developing to be involved in these processes.
I'd agree. The demand for data science and data scientists continues to grow in the economy. And what you see happening with automation is that things that used to be very tedious for programmers and analysts and data scientists to do become easier because tools migrate to a higher level. And it doesn't mean that you're no longer using tools or grappling with tools, and it doesn't mean that you need to know any less about them. It means that the level of knowledge that you need to know, I would say, is at a higher and more conceptual level. And the lack of that knowledge could even cause greater harm, because with automated tools where you think you just have to push some stuff in and see what happens at the other end without really being aware of what it's doing, has a much greater potential for damage than if you have to build something from scratch and build something that's a bit kludgy and kind of not that powerful. So this is actually, there's nothing new about all this. I think the same trend has happened in history in the past, where the level of the creativity that humans bring to problems moves to a higher level. You're no longer screwing the bolts together, you're using the pieces of machinery that have been created elsewhere to perform a higher purpose.
Mm-hmm.
Excellent.
Yeah, one last thing I'll add there real quick is that, even as you consider tools that actually help, say, write code in an automated fashion, like GitHub Copilot, for example, even as those tools get better and maybe as they, become adopted by people all across the industry, and the industry just becomes much more productive at writing code, in my opinion, that just means there will be more of a demand for code, because, okay, maybe we're solving certain problems that organizations are having now related to we don't have enough people writing code. But once that's done, there's going to be different desires that need to be met, different work that needs to be done.
You may see an evolution maybe away from the pure computer science stuff towards more business applications or organizational needs, and solutions architecture and overall engineering solutions, as opposed to deep down in the code.
Yeah, I'm gonna get to the next question after this, but if anyone who watches my channel and live stream know, I talk all the time, like I beat it like a dead horse, about having context and disciplined knowledge about whatever you're coding about, like having the broad sort of picture. And I think that sort of goes to the idea of it's not going to end, it's just going to shift and evolve and change as it sort of always has. So a little bit different take here. I think this is probably a bigger issue. So George asks, hello from Thailand. What are your thoughts on Google? And I'll say any company like a Google, on Google's philosophy on responsible data science since they let go Margaret Mitchell and Timnit Gebru from their ethical AI team. So I think what we should do here is broaden this out into maybe a brief discussion about ethical AI or responsible data science in these sorts of companies like the Googles and the Facebook / Metas and all that. How do you see, some of these companies from your view approaching these issues of ethical and responsible?
Peter, do you want to take an initial stab, or I can do it?
Yeah, I don't have super strong views on this because I think it's a really complicated question. Take, for example, the whole issue of Facebook and Meta and, for lack of a better term, censorship. At the one end of the scale, you have the harm that can come from toxic, belligerent, and manipulative communications that happen. And on the other hand, misinformation. On the other hand, you have the specter of corporate censorship of what many people are saying should be free speech. And okay, should you have the government do that? Well, that's not such a good idea either. And I sort of sympathize with them being between a rock and a hard place on how do companies respond to this. Now, this is something where I think different individuals may have different views. The EU is coming up with a new package that succeeds or supplements GDPR that does address the misbehavior of on social media, I should say. I'm not going to say necessarily of social media, but I hesitate to blame the companies. I think what you have here is a technology that's out of the bag, and it's difficult to see. It's like water running down a hill. You could put some boulders in front of it here, and it's going to go somewhere else. This is Pandora's box, and I confess I'm a little pessimistic on this, and I'm not sure that any one company or government has the ability to curb humans' almost juvenile antagonistic behavior on social media in ways that are harmful, that it's coming from the mass of people more than it is from companies.
Yeah, Grant, I want to get.
Let's hear Grant.
Before I hear from Grant, I think one thing I want to point out, I think it occurred to me really what this question is really trying to get at, I think, is that we're here talking about responsible data science, and we're trying to get students and our viewers to be responsible data scientists. And then these companies have data scientists inside their own companies that are being responsible, but when they bring something up, they get jettisoned or, let go or whatever else by being responsible data scientists within the company. See, Grant, any thoughts?
Yeah. And George, I appreciate you asking this question. This is something that I think is on my mind and a lot of other people's minds. And a little bit more context for those who don't know, Timnit Gebru and Margaret Meg, I think she goes by Meg, so I'll just say Meg Mitchell, but know that that's Margaret Mitchell. Timnit Gebru and Meg Mitchell were both directors within Google Brain's responsible AI team. And they were, at least from the outside, seemingly quite well liked and respected researchers, but they were each let go within a few months of each other for reasons that are not fully clear, but from their own sort of point of view, it's in large part because they, as part of their business function, they were doing research on the social impacts and the environmental impacts of the large language models and other large models that Google was building and using. And a lot of what they and their own research were finding was these models so far have produced harms. They fail in sort of expected, but so far unavoidable ways that the language models maybe will, happily tell you how to create a bomb if you ask nicely, or, maybe the language models, just training them, it uses, as much energy as a, small country needs to power everything in the country for a few days. And a lot of the questions they are asking are, why are we doing this? Is it worth it? And, based on the sorts of evaluations we're doing, we're saying, no, it's not. And that gets at a core issue where the people who are, doing this research, especially in the cutting edge now, are often embedded within these organizations. And sometimes the research they write is going to say, what our organization is doing and investing all of our money in is something we should stop. And this is a tension that I don't think is going to go away. I think Google has recognized that it's a business and reputational risk for them to have very prolific researchers in this space within their company. And I think that's in part why Meg and Timnit were both let go from Google. Facebook also has wound down parts of their responsible data science, responsible AI research team. And yeah, it just seems like something where the people who maybe have the most power to speak to these sorts of issues are going to be the ones who are most likely to be silenced because it directly impacts the bottom line of the business that pays their salary. All that being said, that's a lot of pessimism. I do think that Google and Meta and all these other large tech companies, they legitimately do not want to cause unintended harm with their models. They don't want to discriminate against any ethnic group or any person with any gender identity or sexual orientation. However, they do want to be able to control the narrative around what sort of issues maybe are coming out of their models as they come up.
Yeah,
Yeah, it's
Facebook did research that found significant harm for teenage girls, I think, resulting from certain things, and they made very minor adjustments, and the issue was raised within the company, and the conclusion looking at it from the outside was that they just didn't want to forego the revenue that they were getting from this Instagram platform in that area. Now, I'll point out here that I think the issues for huge social media companies are very different from the ones that a legacy, any one of 1,000 other companies using machine learning models for prosaic purposes might face. And most data scientists, well, I'm going to say most, henceforth, are probably going to be employed in projects that are not related to social media. I think and they're the ones where I'm not quite so pessimistic. I think that higher awareness on their part can avoid the sort of harm that results from unintended applications of machine learning models that are biased.
Agreed.
But I agree with Grant and the pessimism with respect to social media. I'm not sure that, I just don't see where the solution lies.
Yeah, it's a thorny topic. We could talk about that forever. So I'm going to pull up the next question. If you're still in the chat and everything, I'm going to do the first giveaway for a copy of their book. I'm going to do the first giveaway here in like 5 minutes or so, and then we'll do the giveaway for the next book a few minutes after that. So make sure you stick around in the chat for the giveaways. The next question is from Razikata. I'm saying that right? And the question is, interested to hear your thoughts about the over-cleaning of data as a form of irresponsible data science. How to identify and prevent that. So either you all want to take this question or have thoughts on it?
Maybe clarify by what's meant by over-cleaning of data, unless that's immediately apparent to you, Grant.
I mean, I definitely have some ideas that come to mind. So for example, maybe someone who's relatively new to data science, if you see maybe a bunch of outliers in your data set, or you have a categorical variable and you see a category that you maybe were not told about or have not seen before, maybe you'd be inclined to drop those or combine them, with categories that are already existing. And if those outlier values or those new categories are legitimate, then that would actually be something that I think maybe would fall under this umbrella of, we'll say, over cleaning, because you're going to need to get as much complexity out of the data into your model as you can. And if you're unnecessarily compressing it and saying, oh, maybe if we're predicting home prices in a neighborhood and 5 houses or a given size and have this many bathrooms and this many floors, but then there's one very large mansion in that neighborhood, you probably actually don't want to discount the mansion, because if there's already one mansion in that neighborhood, there's probably going to be other neighborhoods that are similar where you'll have that sort of distribution, and you're going to want to have your model seeing that data. Similarly, if you have missing values in your data, you don't necessarily just want to impute those randomly or drop all those observations, because those values, they may not be missing at random. There's like a laundry list of like other sort of practical data science tips in the subject that come to mind, but I'll stop there.
Part of this can be addressed if you're very explicit and clear on what steps were taken to clean the data, so that somebody else examining the project can make their own judgment about whether this was reasonable or not. There's also, now that you mentioned those things, Grant, the longstanding predating machine learning tendency of statistical analysis to have a theory in search of data. And if you are looking for data that suits a particular theory, maybe that's what could be qualified as overcleaning of data. I don't think so, but thought did occur to me.
Okay. Next question actually is about the course, and that is, I guess, for statistics.com in general. Are there any projects or project-based courses at statistics.com, and in this course in particular, something where the student is led through the entire life cycle of a research problem?
Not in one course by itself. We have certificate programs that cover different things, such as basic statistics, database queries, getting data out of a database, the modeling, evaluation of models, where you would get that life cycle view, pick it up over the course of a number of different courses, but there's not a specific course that is devoted to following a project through the life cycle. One of the issues here is that the early stages of the life cycle, prepping the data, cleaning the data, are quite time consuming, and challenging in almost a clerical way, that are they're worth knowing about and teaching and understanding, but they can be challenging to teach just for resource issues.
Okay, thank you. Excellent. Keep our questions going. We're going to go for at max 20 more minutes, everyone. So if you have any questions, now's the time to put them in there. We're going to take a few more questions, and then we're going to do the 2 giveaways, and that will be our stream for the day. So the next question is, Nasrullah asks, how do you see different roles changing in data science, such as data engineer, machine learning engineer, data analyst? Again, this kind of goes back to the automation theme, maybe, with automation in place, but about the different roles in data science.
So I'll take the initial stab at that. Man, I mean, it's a great question, because I think what I said earlier still stands, and that this is a field that's growing, and there's just going to be more demand for the people who have the skills and experience that will let them do the jobs that you listed, Nasrullah. However, what those individual jobs involve in the day-to-day and what sort of tools are being used, I do think will change. I don't necessarily want to speak to all of them, but I will say that for anyone who is working with large language models, or more and more advanced sort of transformer neural network architectures in the future, as seems likely to me that will become more widespread, it's going to become, I think, much more common for people in roles where they work with these systems, that you will have software that gives you an interface for, after a particular modeling run, you have like a visual representation or some sort of tabular representation of all of the mislabeled data, and going through and actually looking at that data, looking at how that mislabeled data actually breaks out into clusters that maybe you have some mathematical formula to describe, and then manually fixing those problems, and then iteratively doing that process through and through. I guess generally, if I were to summarize that, it would be our jobs are going to be much more about tuning large models that were built by other people for general purposes, and fine-tuning them to our specific use cases. And yeah, that's just a transition, I think, that's underway, and we'll see that more and more over the next few years.
Okay.
At the recent joint statistical meetings, I heard a keynote talk by blanking on the name now, but he was asked the question, because he did a sort of historical survey of great statistical advances in the last half century. What do you foresee coming down the road as far as new statistical advances in the next quarter century? And he sort of surprised everyone in the room by saying none. He doesn't see any role for huge conceptual breakthroughs in statistics, machine learning. Rather, it's going to be issues of data engineering and machine learning engineering, such as Nasrullah identified in the question. He gave as an example sort of the models for self-driving cars. That's the improvements in that, and the application, the generation of similar models for other applications where you want machine learning to take a pretty hefty role in deciding what happens, are going to be getting the data in, understanding the data, as Grant said, identifying anomalies in the data, because anomalies can be very important if you're trying to get a car that has accident rate of 1 in 10,000, then an anomaly rate of 1 in 1,000 is huge. That if you end up going through a stop sign when you shouldn't. And those are all more issues of surfacing the data, the problems, tuning the engine, as Grant said, which involves understanding what it's trying to do, and getting the data flow where you can get the data into the system so that the neural net can learn more. These anomalous cases are why you need such huge data, because they occur so rarely, and they're the ones that have to be learned.
Excellent. So we're going to get to a couple more questions, but while we're doing the last few questions, we're going to do the first giveaway. So everybody, if you're interested in a signed copy of Peter and Grant's book, we're going to do a giveaway. So put #responsible in the chat, whether you're on YouTube or LinkedIn, put #responsible, and we'll collect those hashtags over the next few minutes while they answer the next question, and then we'll do our next giveaway. So #responsible in the chat if you want to enter yourself for a free copy of the book. Okay. All right. This is my first time doing, we got some entries. So we'll get back to that in a second. So while we're waiting for entries to come in, let's get back to another question. And I think this is a very good one, especially for viewers here. Abdul asks, we have 2 pathways to get into data science, a degree or certification. Which option is more recommendable, and how different companies look to this matter when hiring a data scientist?
That's a good question. I'll take a lead. Different companies are very different, as far as how they hire, and some may go by the old school network. Others will say, we don't care where you went to school. We're going to have our own exam process for you getting in. That's particularly true in the high-tech industry. So I don't see a universal answer to this question, but it's important that somebody look very carefully at what the content of a degree or the content of a certification is. For example, our certificates that we offer at statistics.com are roughly the equivalent of a master's degree in data science. And then affordability is something you also want to look at. ERI, Elder Research, which owns statistics.com, gets people from schools, but they also get people from completely outside of data science with an analytical background, and help train them up to be data scientists to suit the need that they have at the moment. This whole trend towards automation that we've been talking about sort of means that a degree that you got 6 or 7 years ago may not give you everything that you need nowadays. So that in that case, speed of getting the basic knowledge of the day, plus the ability to keep augmenting it in the future, is more to the point. But Grant, you give
Yeah, it was a good question.
Sure. Yeah, I mean, what I would add to that is that, and this is in large part drawn from my own sort of anecdotal understanding. I think that this is pretty accurate, but I, of course, may be wrong. A lot of the companies that are based out of Silicon Valley or San Francisco, or large tech companies or startups that are really innovative and trying to move quick in this space, there is definitely a culture of not valuing credentials that highly. Really what matters the most is experience. So I would say, especially if you're looking at companies in sort of that tech space or that geographic area, a degree will only minimally help you in as much as it gives you experience that you can speak about. And you can get that experience just by getting a certification. But with all companies, it's going to behoove you to have some sort of case studies of work that you've done that you can speak to and write down on your resume, maybe some repos on your GitHub or some sort of other public internet presence that can demonstrate that you've done this work before. And I think generally any company that is going to look at that sort of information, and if you have that information, that is going to be just a very strong point for you, more so than saying, oh, I have a bachelor's or a master's or a PhD in, some sort of subject that's related to this field.
Yeah, I always argued that, hire a degree program and being involved in things like that, if you do it right, if you really take advantage of it, can really plug you into a network. You can have, you can be a part of research projects. You can be on part of research teams at some level. I did that. So there are other ancillary benefits that can come that you may not, get in a certificate type program. So there are, but I think what really interests people or concerns individuals that are on my streams and stuff is how employers view that. If you come in with a certificate or something like that versus someone with a degree, are you at a large disadvantage now? And I guess it just depends, even though it seems to be where things are going.
Yeah, I would just say, and I'm also saying this as someone who interviews people for data science and data engineering roles at Elder Research. If you do not have a degree, but you have equivalent experience, that is just as good, if not better.
Excellent. All right, let's have some fun here. We'll do another question or two after this, but let's do our first giveaway. So we're going to draw for a copy of the book. Drum roll. Let's see what we get here. Who are we going to end up? Who's going to be? Oh. All right, Parvez, you win. That's a pretty cool graphic right there. That's pretty nice. That's some data science work. Parev, congratulations. Make sure you reach out to me on, I'm going to write everything down here. Make sure you reach out to me on LinkedIn, which is preferable. Pretty much everyone is on LinkedIn now. Reach out to me, send me a message on LinkedIn is preferable, or through my website. Send me a message through my website, and we can take care of that. We do have one more giveaway, everybody. So if you didn't get that one, we're going to do one more here in a few minutes. So Parvez, congratulations. All right, so another question or two, and then we'll do the next giveaway. All right, so let me get this off the screen and bring up the next question. Let's see, I lost it. Where'd I go? This may be one. There we go. How do we see data science from the business analyst or business analysis, or maybe business analyst perspective? I actually had this conversation with some of my coworkers at Cengage yesterday on a Slack channel about, someone made the argument, or some article, I think it was on Forbes, made the argument that data scientist and business analyst or business analysis is merging into one role or one sort of responsibility. I'm not sure I see it that way quite yet, but this actually goes to that question by complete serendipity. So either you have any thoughts on data science and analytics or analysis perspective, and how those two roles maybe are different or the same.
I've always thought of the best sort of business analysis as being the ability to take an complex and inchoate business problem and reduce it to something that you could solve sort of on the back of an envelope by making appropriate assumptions and bringing to bear good experience and knowledge of the world. And I don't see that as being relevant, as being machine learning at all. That's more the synthesis of good understanding of the world and ability to, instead of just picking a strategy out of thin air or out of your gut instinct, bringing to bear some data, but often the data doesn't have to be big data. It can be just some knowledge of the population of the United States or the number of cars per person in India or whatever. And then that's sort of marketing and business strategy analysis. I'm not sure if that's what the question was asking, but I see that as very separate from data science and machine learning.
Yeah, but I think what I told my coworker was I see, as of right now, I see having a primary and a secondary. Like, let's say, like, this is just like academic a metaphor, but like data science is your major, maybe business analyst is a minor, or maybe it's reversed. Maybe like business analyst is your major and like data science is your minor, and one sort of complements the other, but they're not subsumed into each other.
From a business and from a company strategy and marketing standpoint, you do that back of the envelope stuff to make sure that your pinball is in the right part of the pinball machine before you start getting really detailed with statistical and machine learning and analysis and bringing to bear data. You don't want to spend weeks and months of analyst effort and all kinds of data only to find out you're solving the wrong problem.
Right. Okay. We're going to do one more giveaway, maybe one more question, and then we're going to wrap this live stream up, which has gone very well. I'm very happy with how it has turned out. So next giveaway for a copy of this, free copy of this book, Practical Statistics for Data Scientists. Use the hashtag practical in the chat, just like we did for responsible, but this time it's practical. So go ahead and put your entries in there. You can't win both. So Parvez, sorry, can't win both. But yeah, put that in the chat and we'll do the draw for that after this next and maybe last question. So the question is, Raghav asks, I have loved how data science has evolved over the years, merging different platforms. Do you think that data science will exist in 10 years? Or will the evolution continue? What do you think the next platform is that will merge into data science? So there's several questions there. Don't have to answer each one of them. But a little prognosticating or, looking into the future of where do you see data science going?
All right, your turn, Grant.
Yeah, no, I mean, this is such a, thank you, Raghav. I mean, this is such a monster of a question. There's so many things one can say about
we can't
this,
get to everything, but we'll do our best.
This is like, record like a 2-hour podcast about it, but it generally, yes, DS will exist in 10 years plus as a field. I'd be very surprised if it didn't. It will continue to evolve. And I think a lot of the ways we've discussed where, maybe much of the work that we're doing in data science is less about, what sort of changes do we make to a particular model and more what sort of data do we supply to that model? How do we make sure that model is transparent? How do we iteratively improve that model or fine tune it to our own data over time? So, data science as a field, again, definitely will exist, but maybe our focus will shift. I'll say if we're thinking about like a sector of the economy or industry, I think you're going to see a lot more data science and we'll just say AI and machine learning more generally taking over sort of the art space. I think, models like Stable Diffusion and, DALL-E or, things like that, they make it very easy to generate very high quality images. And there's going to be a lot of demand for that. And I think there's going to be sort of a cottage industry springing up around how do you get the best sorts of images from these advanced models, because we don't fully understand how they work yet.
I think that I once asked Gregory Piatetsky, who is the founder of Katie Nuggets, a big newsletter in the field, about these different terms. This was 8 or 9 years ago, before data science became so embedded as a term. And he said, well, the key here is that it's become a term that is used in job descriptions. Data scientist, as opposed to machine learning specialist or data analyst. And until something comes along to knock it out as a job descriptor, a position description out of Indeed and other recruiting platforms, I think data science as a term will continue to exist.
Excellent. All right, we're going to do the last giveaway here in a second. Before we do that, though, any last thoughts or comments or things either of you might have thought about with respect to responsible data science over the course of this conversation that you didn't think of then but do now that you might want to share with everyone on the stream, and then we'll do the last giveaway, and that'll be it. So any final thoughts?
I'll just say that I think there's a lot to be learned for analysts. We talked about the problems if you're in the high-tech industry or social media, but that's really a minority of actual companies, a small minority that actually employ data science. And so there's a lot of doable work in the field of ethics in data science for everybody in almost every field that is being applied.
Mm-hmm. Yeah, and I'll add to that just by reiterating that the sorts of issues that we've discussed, maybe they're confined to like certain companies or certain industries, but responsible data science and the sorts of ways of thinking about how to reconceptualize your models and work you do in the actual practical tools and steps you may take to make your models and your data science more responsible, that is applicable to everybody. Even if you're not doing a data science project that's going to be deployed in the real world or have a large negative impact if it goes wrong, having more insight into how your models work, into how balanced your data set is, into the nature of your model's errors, that is relevant to anyone doing this work. And I think yet another reason to keep these sorts of subjects in mind.
Yeah, I was gonna say, as I was reading the book, I'm not a big coder myself, but just the narrative, like the concepts, were extremely valuable for me without even going in and doing all the coding stuff, which I might do at some point. But just the idea, just the ideas around it are very important. So we're gonna do the last giveaway here in a second, but some people in the chat just wanted to thank you both. Thank you so much for Peter and Grant for answering all of our questions. Absolutely. Now, Julia says, thank you so much for Peter and Grant, and thanks to Brandon as well. You all are very welcome. We are here for you. So let's do the last giveaway for a copy of this book, a signed copy, I believe, of this book. Let's see who our lucky winner is. Here we go. Da-da-da-da. I should like music for this or something. They need some. Oh, so Piper Tripp wanted his name taken out, so we're actually going to draw again. All right. Let's see here.
It's great that they have this built in.
Isn't that pretty cool?
Yeah.
Ah!
Oh no!
I tell you
the
what.
odds. Someone calculate
This
the
is.
odds.
I know this is actually a question. So the person, so Piper's like LOL figures. Hey, there we go. All right. Razi Kata actually had some great questions that were submitted as well. So congratulations, Razi Kata. I hope I'm saying that correctly. Please message me, preferably on LinkedIn, so I can just verify it's you or whatever. But you can also message me through my website. But yeah, if you have LinkedIn, just send me a message on there, and I will send you to the person who can fulfill your winning giveaway. All right, so. All right, I'll take this off the stream. All right, so let's wrap this up. So I want to thank Peter and Grant for coming on the live stream today. I know Grant's at a conference, I think. Peter's obviously a very, very a busy person as well. So I want to thank them for coming on and answering your all's questions and taking their valuable time to do that. So I'm going to go ahead and remove them from the stream. I'll wrap up, and I will see everyone. Well, actually, I'm going to talk to everyone on the stream, but I'm going to go ahead and remove them, and then guys, we'll do a brief after this. So
Thank you, Brandon.
Awesome.
thank you.
Thank you, Brandon. Thanks, everyone.
All right, everybody. So that wraps up our stream about responsible data science. So I hope this is a new thing that we sort of did. Was very excited to have them come on. It takes some pressure off me, honestly, because I don't have to sit there and fill all the time. But I just want to thank you all for coming on and submitting your questions to them. I hope some of their comments were valuable for you, and you were thinking about things in a different way. And of course, hopefully you maybe have some interest in doing the Responsible Data Science course on statistics.com. Of course, remember that there's a discount code if you do that. So, I can attest from people I know. I know other people that teach, like some of the authors I work with, at least one I know of, Cengage teaches on statistics.com. So it's great content. So I hope you all consider doing some course or program there with the code that I have in the description. So just to wrap up sort of where I'll be in the next couple of weeks. So just a reminder, I do have new videos coming out. There's a new video coming out Monday morning about time series. It's the part of the new series on time series. Number 2 is that I will be overseas for a couple of weeks over the next, over the next month. So my live streaming may or may not happen on the usual schedule. I'm going to try, but it's going to be a lot different in different time zones, obviously, and stuff. So I will let you know if I'm going to live stream, usually the Wednesday before the live stream. So, you all are so welcome. You're very welcome, Angela. Thank you so much. You are very, very welcome. So thanks, Brandon, for bringing them on. Absolutely. You're very welcome. So everybody, what I'm going to do is go ahead and wrap this up, and I will see you all again soon. And never stop learning. Bye-bye.